Okay, guys. It's just a minute after the top of the hour, so I'm happy to proceed unless I'm told not to otherwise. So look, I'm going to start off by first of all thanking everybody for joining today's webinar. We hope you find it informative. The title of today's webinar is Accessing Efficient Energy Modeling in Revit using Fenestra Pro version 7. Just to kind of, I suppose, get a sense of just a general overview. What we want to try and do today is we'll do a general introduction to Fenestra version 7, and then we'll talk specifically around the actual energy model analysis tool that's part of the onboarding process, and we'll touch on that. Unusually, today's presentation is brought to you by both founders, it's usually one or the other, but today we're both on the call. Again, we're going to, I suppose, just to, I'm going to briefly introduce myself and Simon, and then I'll talk through what we're going to cover today, and Simon will take it up then in the second half of today's presentation. So David Palmer is my name. Great to be on the call with everybody. I'm the founder and CEO of Fenestra Pro. I'm an architect by trade. I have a master's in facade engineering. I was a director in an architectural firm, and I also do some lecturing in the Dublin School of Architecture here in Dublin, in Ireland. My colleague Simon is also on the call. So Simon's the other founder of Fenestra Pro. Simon is again as an architect with a master's in advanced energy and environmental systems. Also was a director of an architectural firm for over 10 years. And Simon is a lead green associate. So hopefully that gives you a very brief introduction. And I do see some names that we know on the list that are coming through. So it's good to see everybody. Nice to see some familiar faces there. So the agenda for today's call, as I briefly mentioned, what we're going to start off with, we'll do a brief introduction to the company, Fenestra Pro. We'll talk about the impact of the facade, particularly around how it impacts on operational and embodied energy as well. We'll talk about user insights, so those kind of metrics that enable you to optimize the design of your facade. We'll do an introduction to the latest version of Fenestra Pro, which we just recently launched in February at an event in Autodesk's European headquarters here in Dublin. We'll talk then, I'll probably hand over at that point then to Simon. Simon's going to talk through, how to access your energy analysis model and some of the tools that we've built as part of version 7, which enables you to audit and validate your energy model as part of the onboarding process within Fenestra Pro itself. So you get a sense of that hopefully by the end of today. And then we'll open it up to the floor for a question and answers session, which hopefully will address some of your questions. In the meantime, if you do have any burning questions or questions you want to just put in for the record that we can deal with as part of that questions and answer session, please post those questions into the webinar chat. If it's a burning question, Simon or Meg, who's in charge of the webinar, can interrupt us and we can answer the questions, but otherwise we can hold off until the Q&A session towards the end, where we can respond to any questions that you might have. Okay, so look, just I suppose as an introduction or a brief overview to describe what we do here. So Fenestra Pro provides BIM and web-based software for facade design and glazing specification to optimize the design of the facade and the building for energy efficiency. One of the things that, I suppose to point out is that we are an approved tool set under the American Institute of Architects 2030 palette. And that's a resource that's made available through the AIA for the design of zero carbon, adaptable and resilient buildings. So again, very much focused on heading towards net zero. They have a number of approved tools that support energy efficient design, and I'm delighted to say Fenestra Pro is one of those tools. When we talk about the impact of the facade, I think it's, obviously the facade is two kind of core things that we generally refer to. So very much it is the building in conjunction with, I suppose, the shape or the mass of the building. The facade is very much the building's architecture. It's that kind of face of the building to the public in terms of, what that building is going to look like, how it sits in the context and its environment and so on. But very importantly, the second aspect of it is it's a major control. It's that intermediary between your internal and your external environments. And in fact, it controls over half of the energy being used in a building. So if you think about it in terms of looking at how that breaks down, 26% of energy is used for heating and cooling the building. So again, what you're trying to do is maximize your heat gain, natural heat gain from the sun through your glazing arrangements, but also control that heat gain so you don't get overheating. And believe it or not, overheating or cooling the building costs 3 times that of trying to heat the building. So again, trying to manage that heat gain in that kind of sweet spot, typically between 15 and 25 watts per meter squared, is what you're trying to do to get that optimal performance from your facade and really prevent that overheating. In terms of artificial lighting, represents typically around close to 20%, just short of 20% of the energy being used in the building. Obviously, you've got nighttime lighting, which can't be, I suppose, can't be addressed as part of this. But again, trying to maximize your daylight, that reduces the requirement for artificial light during daylight hours. And then 12% is, I suppose, is in terms of heat loss, and that's heat loss through your facade, and I think that's around 2%, or sorry, between your roof, your floor, which I think is 2% each, your walls is 2%, and your glazing is about 6%. So half of the energy, heat loss is lost to your glazing, because the glazing doesn't perform as well as a highly insulated wall. Having said that, there are obviously lots of benefits, not, I suppose, qualitative benefits in terms of, that connection with your outside visible sky, all those things that kind of, have a positive impact on the occupants within the building. But also, I suppose, those measurable aspects in terms of what's quantifiable within that. Additionally, and I suppose what's becoming more and more to the fore these days is embodied carbon, and we'll touch on that a little bit later. But the envelope itself is typically responsible for around a quarter of the embodied carbon that goes into the construction of buildings, and you can see how that breaks down. So again, I suppose getting those kind of balances, the balance between operational and embodied carbon is a key part, or those kind of key metrics that looks to drive, I suppose, your design and your consideration in relation to material specification. You touched on it briefly there. What are the metrics that matter? So we talk about operational and embodied carbon. They're very high level overviews in terms of the energy use within the building construction stage and operational stage. But I suppose to optimize the performance of the building, and in particular the performance of the facade itself, we generally would look at kind of those kind of three key parameters that we look in terms of the overall performance. And we see, I suppose, managing your percentage, the amount of glass, the percentage glazing, or the amount of glazing that you have on the building, and understanding the U values to enhance thermal performance. So again, looking at the overall requirement, and this is typically driven by code, looking at the overall requirement for the overall thermal performance of the building, and then the minimal thermal performance of the building in relation, or the elements of the building in relation to glass, wall, floor, roof that we just touched on a moment ago. So again, using those kind of parameters to drive glass to wall ratio and thermal performance is a key consideration. We talked about it a moment ago, and optimizing those solar gains to reduce the requirement for heating and for cooling. And then similarly, maximizing the amount of daylight that's coming into the building to reduce the requirement for artificial lighting. And the thing about these, I suppose, three components is that they very often work against each other. And again, if you can think about it, we talked about, how the weak point in terms of the thermal performance is your glazing arrangement on the facade. But actually, when you look at that, the more glass you have, obviously, the weaker your thermal performance. The more glass you have, the better your daylighting. And again, the more glass you have, you've got to consider how you can control that heat gain. And that can be done obviously with solar control glazing or shading, for example. But these things tend to work against each other. Major components is not only glass specification, as it says in the slide there, but it's also the configuration of your glazing. So again, things like percentage glazing, distribution of glazing, configuration of your glazing arrangement, and of course the specification, where you can manage a lot of that with solar control glass in terms of minimizing your overheat, but also improving your thermal performance for better performing thermal glazing. As I mentioned at the top of the call, we've recently launched version 7 of our software. And I suppose Vanessa Pro version 7, just to explain exactly what that is, it's an Autodesk Revit application that demonstrates the environmental impacts of your facade design to optimize energy efficiency within the BIM workflow. So there's two key components there. That's optimizing energy efficiency. So again, we have a thing here in the office where we talk about what's measurable is manageable. And that idea that, if you understand the implications of your design decisions in relation to the facade and the performance of the facade, you can optimize that and very quickly iterate. Because we are a plugin within Revit, we're very connected with the Revit model, so we're able to get that data in real time, the thermal, solar, passive solar heat gain, natural daylight in real time within the BIM workflow. So that's the other component, is actually being within the BIM workflow itself. So therefore, you've got that connection with the Revit model. You can generate configurations. You can look at, I suppose, alternative glazing specifications and so on to optimize. And again, it's that idea of using Fenestra Pro to optimize, and we'll see later in the presentation how we can use something like Insight then to analyze in more detail. So it's about optimization, it's about design, and very much working from the conceptual stages within the design process all the way through to detailed design. I suppose, look, again, we talked about it there, facade geometry, your percentage glazing, distribution, configuration of glazing. So again, the facade geometry is one of the things that we look at, component specification. So that's the materiality aspect of it, where we look at, I suppose, looking at, the various considerations associated with the wall performance. And typically that's driven by U value. With your glazing performance, you're looking at things like, solar heat, heat gain coefficient, visible light transmittance, and of course the U value. And within the application, we generate huge amounts of data. So if you can look at it, we can look at the building in its entirety, where we're looking at the overall performance, average performance across the multiple facades and multiple orientations. We can break it down to one facade or one orientated facade. We can break it down to one space within the building. And all the while, within each of those elements or components of the building, we've got the heat gain on a daily basis that we break that down onto a monthly basis. We've got, you've got your daylight levels, you've got your thermal performance levels. And again, as you look at kind of the larger the building, the more information. So we have the ability to generate that information and that data and export it from Revit into our own platform, where you can customize your own charts and graphs and present your story with the building in terms of how you've optimized the building itself. In terms of what we try and do, again, I suppose what we're looking to do is support you to design more energy efficient buildings, being able to establish and apply optimal glazing configurations and specifications, and demonstrate code compliance, but also optimizing the facade performance. So code compliance very much related to the thermal performance, and we'll talk a little bit about that in a short while, but also then optimization for heat gain and daylighting as well. I suppose by eliminating, by getting your configuration and your specification right from the get-go, we're very much looking at eliminating late-stage redesign, particularly when the engineers start calculating the requirements for their HVAC systems and so on, and identify issues that have to be addressed in that redesign loop that typically happens at the end of the process. We front load that, so giving you an understanding from conceptual design all the way through to detailed design. We're able to streamline your workflow and improve your design process quite significantly, and we've got some testimony to that fact as well. To talk a little bit, I'm going to actually stop talking for a minute and let the video play, and hopefully that will give you an indication in the first view of what version 7 actually looks like. Okay, so those of you who I guess are familiar with Fenestra Pro and previous versions will notice very much in that particular video the new alternative workflows within Fenestra Pro 7, where we're now able to, I suppose, extract the energy analysis model from Revit, bring it into our own environment and work in conjunction, still connected with the Revit model, but we can work within our own environment whereby we can carry out the analysis in a much more streamlined and faster way, and still be connected to the Revit model. So as we start generating alternative configurations or glass specifications, we can apply them back to the Revit model. Another key advantage to that then is the ability for us to, I suppose, to resolve any modeling issues that may appear. And we're going to talk a lot about that now in a moment, as that's the main focus of today's presentation. And we'll hand over to Simon. But before we do that, I'm going to talk a little bit about some sample functionality just to give you a sense of it. Again, very much at that conceptual design stage, we're looking at, you know, multiple functionalities within that. And I'll let this video play as I talk through what that looks like. So at that early stage, you know, you're very much establishing things like glass to wall ratio based on the overall thermal performance. So for example, if we look at you know, the requirements for the overall thermal performance of the building, and we look at then the elemental requirements, we can establish very quickly whether it's 40, 50, 60% glazing. And again, we can use code to manage that. So in terms of ensuring that we're compliant with code. At that, you know, I suppose at that stage, then we're also looking at the optimal distribution. So we can automatically configure or distribute the glass around the building, you know, to equalize the heat gains, for example. And typically you end up with more glazing on your south than you do on your north. But again, just, you know, then you've got to address that south facing glazing. We do have the ability to override that. So for example, if that south-facing facade isn't got enough glass in, you can increase that to whatever it might be, and that could be 80, 90% glazing in terms of those highly glazed facades. And we can then look at, I suppose, how we can distribute the rest of the glass to the rest of the building, so we can lock it down and distribute accordingly. You know, at that early stage, and you probably saw it there a moment ago, we can look at that early stage glazing specification. So we do get some indicators, and you can see here in the dashboard what that looks like. And we can navigate through the facade. We can look at individual components or individual surfaces, spaces within the building, and then look at those alternative glazing specifications. And really at that early stage where you're kind of starting to understand you know, the site location, the orientations, the impact of surrounding buildings, for example, in terms of the shading effect that comes from those, and how that kind of fits in terms of, you know, how you optimize the performance of the glazing, the performance of your facade. And again, you know, looking at kind of maybe, you know, how you might use shading devices, and you can see how a moment ago how it generated alternative shade or alternative depth of canopies and optimal depth of canopies. I mentioned earlier we can export a huge amount of information even at this early stage, and we can configure our own versions of the to tell it your own story. You can look at looking at average heat, you know, the solar load versus the heat gain, and we can look at daylight and heat gain and how those things balance on a facade by facade or surface by surface basis. As we move through, again, you know, as I said, this is you know, we were looking at the conceptual model. So again, as you know, Fenestra Pro very much works in Revit, both from conceptual and into detail design. As we know, Revit is divided into kind of two main components: that early stage massing tools, which we just saw a moment ago, where you've got these kind of paper thin walls and you've got these notional windows, and we can apply and adjust and apply properties to each of those through the application. Whereas when we get into the actual detail Revit models, which is your more common use of Revit, obviously the data that we're looking to manage and control is actually within the Revit model. So again, it's a case of how we apply those property settings into the walls, into your roof in terms of U value, your glazing settings in terms of the glass specification, and your sort of heat gain coefficient, U value, VLT, and so on. Let's play on as we start talking about it. So again, as I mentioned earlier on, and Simon will get into this in a bit more detail, we've got the ability to extract that, I suppose, model data from the energy model itself and bring it into the application, where we can start to look to, you know, search and filter different types of glass and look to apply that to individual surfaces or indeed spaces. That's also connected to the material properties for the manufacturer's website in terms of finding more information about these glass properties. And again, we've got a database, and we should have mentioned this by now, of around I think over 1,000 different glass types from different manufacturers. Key aspect of this is when we select the glass, we can embed it in through the constructions XML file. We can also customize and generate our own glass types, so through Vitro or through Guardians, Vitro's Construct IGU, through Guardians performance calculator, we can actually, generate those glazing, bespoke glazing makeups, whether it's double laminates and heat soaked and toughened, and bring that into Revit through the application as well. But again, very much, looking at those, filtering and sorting by products, custom imports, defining targets. So again, you can see there in that instance now we're looking at, a particular facade, and we can say we want the thermal performance to be a maximum of X, your heat gains to be a maximum of, let's say, 25 watts per meter squared, and your daylight levels to be a minimum of whatever that needs to be. And therefore, the software will automatically filter your glazing selection based on those kind of three considerations. And that's to do with the application of the material on the building, or the product or the glazing on the building itself. And that will give you the ability to select those different glass types. Couple of things just to touch on here, how we can generate the different glazing configurations. So again, we can, what we've seen a moment ago is where we've got a predefined or pre-configured facade. It's already been designed. In this situation, you may have a blank facade and we want to start looking at adding, I think in this case, we're going to start looking at adding punched windows. So we can select the particular glass type. And from that, then we can put in a rough configuration. So your width, your height, your sill height. We can preview it on our own model. And then we can generate it on to the Revit model directly based on what you've selected and what you're looking to achieve. Similarly, we can do that with based on performance targets. So you can say in this particular space, I want to get a heat gain of X. I want to use this particular glass type, and if it's a standard glass type, you might get 2 punch windows, whereas if you use a solar control, you might get 3 or 4 or 5 punch windows as well. Similarly with curtain walls, we're looking to obviously establish the opening, but also establish your glass to panel ratio, your grillage within the curtain wall system as well. And again, all driven predominantly by performance. Shading is one of the things I mentioned that we calculate. So again, we can look at different canopies. So in conceptual modeling, we can actually take a particular surface and optimize that depth of canopy to achieve what you're trying to achieve. So for example, you might select a space that's south facing, and you'll know that, for example, on that south facing facade, you're trying to achieve below 25 watts per meter squared. It'll automatically generate the depth of that shading device for you. In the detail model, we can look at mass objects and how they affect shading. So shading from surrounding buildings, and not only shading from surrounding buildings, but also shading from different forms of shading devices or objects. And again, you saw it a moment ago where we can animate the different shading, and you can see how that affects the building in terms of the sun pattern across the particular year. The last one that I'm going to show before I hand over to Simon is just talk about the detailed thermal performance. What I will say, this is a favorite from the engineers typically, whereby what the tool does, it looks to calculate an overall thermal performance value for the entire facade, and that includes your center pane U value, which is the typical U value you'll refer to when you're talking about glazing. And then look at those kind of variations. So for under the US and NF4C standard, we see that at a 2-inch edge of pane variation in the thermal performance. In the EU, we look at linear heat loss where the frame meets the glazing. We look at the combining the frame thermal performance as well as the opaque components. So when we start getting into that kind of granular level of detail, we're able to get an accurate picture or an accurate calculation of the overall or detailed thermal performance of a curtain wall in conjunction with the overall thermal performance of the facade. So again, we can see how we can look at fairly, in Revit, we can look at custom panels with nested components. So it's a very sophisticated tool that gives us the ability to very quickly calculate that overall thermal performance, which will feed back into your general performance. So before I finish up, just to kind of mention some of the firms that are using Fenestra Pro, so like Skidmore, Owens and Merrill, Jacobs, Page, Henry J. Lyons here in Dublin. And then we've also got, as I said, we've got a glazing database of glass types from Guardian Glass across the world, and it's all regional based information that we provide to the user. And in the US, we also have Vitro architectural glass as well. And just a sample of some of the projects that we have I suppose, that we've used the software, where we look at that particular Kuwait Airport there by ACOM. We've got the Smith and Gill building, I think was in the Middle East, the two US buildings by Skidmore, Owens and Merrill, where we looked at, the one on the bottom left there is one of my favorites, where we've got that kind of very clear vision through the glazing, but yet obviously managing solar control, both in terms of the solar control glazing with that clear vision into the building as well, but also looking at alternative different shading devices. So I think that takes me to my piece. Simon, you want to take over the screen, or how's this going to work smoothly?
Let's try and make this seamless. I'm going to take over the screen, and hopefully you'll see it. All good?
All good.
So, hi everyone. Thanks for joining, and thanks Dave, and thanks for setting the scene, as it were. I'm going to pick it up from here and talk about Revit, really. Some of the really great benefits in Revit, but also some of the challenges, and how we've maybe tried to address some of these challenges, learn from the likes of you guys. And like Dave said, I see a few friendly names there, but also engagement with Autodesk, being Autodesk industry partners, and development network partners, and all this kind of stuff. And then I want to spend maybe 10 minutes, 5-10 minutes talking about it, showing you what we've done in Fenestra Pro for Revit, and then we'll talk about some questions, and maybe even think about some of the things that we're doing in Fenestra Pro going forward. Just to pick up on Revit, so I think Dave gave a good sense of Fenestra Pro, particularly on the Revit side, and how we leverage the Revit data, the building information model data, from very early conceptual stage, where it's quite broad stroke. It's like very form finding and conceptual massing, or whatever that might be, right through to quite detailed stage, where we're looking at panels and spandrels and frames, and how they interact together, etc. So someone said to me yesterday, which I thought was a really great thing, actually, like Revit, Revit's greatest strengths are also its biggest weaknesses. Like, it's a huge tool, as I think a lot of us know. There's loads of features and loads of things you can do, and there's lots of different ways you can do the same thing. If we take 10 people to model the same building, we're going to get 10 different versions of that building, right? We take 100 people, we get 100 different versions, doing it different ways, different mistakes, different routes to the same end. And from an energy analysis or a performance analysis point of view, that can be problematic. One of the ways that Autodesk have looked to deal with it is through the energy analytical model. So in other words, from your architectural model, Revit will generate what they call an EAM, an energy analysis or an analytical model, that uses like the analytical surfaces and spaces, rather than all the different components and elements and stuff like that. So it will generate this analytical model, looking at all the room bounding elements, looking at all the enclosed rooms and offices and spaces and stuff, and then looking at the different surfaces to those spaces, whether they be opaque wall systems or window and glazing systems, and things like that, and how they all fit together and work together. Fenestra Pro uses that because we are within the Revit environment, and we have no plans to go outside Revit. Like, that was always our thing. We wanted to be a very nimble, very dynamic feedback loop within the Revit environment, that if I make a piece of glazing bigger, I'm going to see my daylight change, or I'm going to see my thermal performance change. So we leverage that energy analytical model in the Revit environment to really do that. There's lots of things we can do with that as well. There's lots of settings and different parameters that you can drive within Revit, etc., etc. Some of them are quite simple. Some of them are a little bit more sophisticated, a little bit more complex. But what we've tried to do is maybe take some of the mystery out of that, and we've tried to provide a seamless kind of intuitive way for the user to access it through Fenestra Pro. Now, that EAM, that energy analytical model, has caused us problems in the past. We've been going a few years. We've been Autodesk industry partners for a few years. And as you can imagine, Fenestra Pro has evolved quite significantly over that time. And one of the biggest evolutions as part of version 7 is how we treat and deal with the energy analytical model. If I talk about some of the problems, first of all, and then I'll talk about how we've solved them, and then I'll show you in Revit. So a couple of the problems with this energy analysis model is it can very often not generate adequately. Now that could be for a couple of reasons. It could be because the model is poorly built, and that we may know that. It might be, oh, like I just had to build this model quickly, and I was under pressure on a deadline, and there's all sorts of components and elements in there that have no properties, or they're not room bounding, or that roof is actually a floor slab, or whatever that might be. It actually looks like a building, but in terms of how that energy system works, it's not being read like an actual building. So it's not generating the energy analysis model correctly. That in the past has been problematic for Fenestra Pro because we leveraged that analysis model to drive the data that we present to the user. When that analysis model isn't generating correctly, it can be hugely frustrating because one of the worst things about it is you don't know why it's not generating correctly, right? So whether it's that floor slab or that roof slab is actually a floor or whatever that might be, it's kind of a little bit hidden, and it's sort of a little bit unintuitive in terms of what's actually wrong and how do I fix it and how do I get set up. So that leads to frustration. And as we all know in this industry, we don't have time to be, spinning our wheels, looking for, you're looking for problems, in the weeds. So that has been an issue in the past. Performance is another problem. And by performance, I mean time, the time to generate, the time to calculate, particularly when you get into more complex models. And that mightn't even be like it's curved and it's domed and all that sort of stuff. It might be purely the amount of information in my Revit model. That can make the energy analysis through the Revit API quite slow and cumbersome. When Fenestra Pro is driving different events, like I'm changing the glass to wall ratio or I'm applying a different type of glazing, that ties up Revit. Every time I do something in the past, it used to rerun the calculation, and it's relying on the Revit API for every function. And because Revit is single threaded, it's again quite frustrating and problematic. And then lastly, there was no real intuitive view. I kind of touched on this a second ago in terms of the clarity to the user. We were just relying on the Revit model and not where the problems were. We were just looking at this whole building, and it was just kind of difficult to display where issues were occurring, what like actual results were happening. And, us as industry partners and development network members, we knew that we could do more, but we were just a little bit hamstrung by the way that we were currently trying to do it, right? So with version 7, we've started applying a couple of solutions, and the main thrust of that solution is a more intuitive on-ramp into the energy analysis model in Revit. We're leveraging the Revit API twice, right, effectively. Once to open the model and display it in a viewer, and once when we close the model and to push the information back from Fenestra Pro into that model. Dave kind of touched on it a couple of times. We have this kind of nice read-write, two-way communication with the Revit model. It's reading the information from it, but then it's also optimizing that information and pushing information back into your model. So we can, display that view, display that EAM in a viewer. We open it through the Revit API. It's all of Fenestra Pro's business logic is now driven through that viewer very quickly, very dynamically. It updates much quicker because we're not reliant on that event over and over again. And then when we close it, it pushes it back to the model. Additionally, we can use that viewer to show you where the issues are, and I'll touch on that now in a second. Navigation as well, I suppose, because we have our viewer, we can now select not only the surfaces but the analytical spaces. So I can look at an office, or I can look at an open plan space where we may have glazing to the south and to the west and to the east, and it's the accumulation of some of those performances that we're really interested in. You know, what's the overall thermal performance? In the past, it was difficult because we had to select this surface and then find this surface, and you know, it was a little bit of an exercise, whereas now we can select the space and it will select all of the analytical surfaces that are relating to it, and we're very much in control now. We, you know, because we can do this much quicker and we can display it in a much more graphical sense, we can do lots and lots of stuff quite quickly, you know. So one of the big things is this, as I said, this onboarding, this integration into the on-ramp into the energy analysis model. We're going to give you advice on the issues that arise. Okay, those issues might be things like your roof is a floor slab, or these are not conditioned spaces, or you may be missing properties. We're big on glazing, as Dave kind of touched on. But Fenestra Pro is not going to know if that's glazing if Revit doesn't know, right? So if it has no properties relating to glazing, how are we going to know what the U value is, what the you know, or what the thermal performance is, what the heat gains are, what the daylighting of the space are? So we're prompting that, we're driving that, and we're asking the user to kind of very intuitively add some values to it. We can visualize those issues and review the warnings in the Revit environment. This is where it always gets hairy when we start doing live demos, but like, look, I'm sure it'll be fine. We'll walk through it. I'm sure lots of you will recognize this, just really simple, you know, Autodesk kind of building, and I'll use it just for a little bit of a demo. If I take one of these kind of glazed panels, you know, in the on this curtain wall assembly, I can see that it is a glazed panel. It even has this type, the family type, as a name, you know, glazed Fenestra Pro, something, 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 SunGuard, SNX, etc. But it has no visual light transmittance. It has no solar heat gain coefficient, no thermal performance, etc. You know, so how are we going to drive some of the values around that? In the past, that was difficult because a user would open up Fenestra Pro and they would go, it's not working. I can't see any daylighting. It's not calculating anything. And, you know, that's one typical, albeit very small, but just something I want to demo here today. One of the big changes we've implemented is, you know, now a ribbon view. So we've kind of broken Fenestra Pro up into components, and more to come later, you know, but like, let's just say this is a detailed model. We're going to start, and you know, the first time you open Fenestra Pro on a model, it will bring you through this process. This information then is just driven back to the model and written to the model, and some of it is cached. So this happens once, right? All of this kind of onboarding that I'm going to walk through, you do it once effectively, and then you don't need to do it again. So first slight delay, I mean about what, 30 seconds or so, is it's generating the Revit energy analytical model, right? So it's exporting all of this data, all of the analytical surfaces, all of the analytical spaces, any material properties or the lack of material properties on this model. And it's starting to assemble them again in Fenestra Pro. Okay, so now that it, you know, it's, let's be honest, it's a small enough model, but it's pretty nimble, it's pretty quick, and it's a lot quicker than we saw in the past. And then what we're seeing is this kind of first step in the onboarding, right? So what we can see is we get obviously a visual representation of the model, and we can see all of these little kind of warnings, right? So remember the glazing family, that like the family type that I highlighted a second ago, it has no analytical properties, right? It's highlighting that as being a major issue in the first instance. If we look at it, we can see there's this family type and there's this family type, and none of those, you know, pieces of glass, none of those panels have any glazing, right? So that's the first thing that's going to be, I'm going to be asked to resolve. It's just very, very simple. We just hit the assign glass button and it tells me, there's your family types. I want to fix one by one, or I can fix them all. And it, I mean, just straight away, it applies just very default properties to that. It's applying a U value, a solar heat gain coefficient, a VLT. So therefore, Fenestra Pro can now start generating those metrics that matter, as Dave put it a couple of minutes ago. Okay, so there's a number of warnings, a number of issues in that Revit model just killed just immediately, and a very intuitive way to just get them resolved. There's still some warnings, you know, remaining. lots of walls with no thermal performances, right? All of these walls, and there's a little parapet there, we probably disregard that. Lots of floors with no thermal performances. And again, we're going to just, get through that very, very quickly, and I'll show you that now in a second. We can also start visualizing some of these issues. So, right, first of all, I can look at the analytical surfaces to my building. Really importantly, I can look at the analytical spaces. And again, this is just how that analytical model is generated. But I can really see that there's 3 stories of conditioned spaces, whether open plan or more cellular offices, that are being generated here. Visually, it looks right to me. I mean, I can see that there's not a story that is completely missing where I'm going, actually, that roof is not room bounding, so therefore they're not, there's no surface, and therefore they're not conditioned spaces. So I'm happy with that. I can start looking at my external walls, my external wall, components, and my internal walls. And again, it's just very visual, very intuitive. It's very it's almost like a sanity check to my model. I can look at my floors, my roofs, etc. Walk through all these different checks. When I'm happy with that, even my, levels, just so that I can make sure that my ground plane isn't set 100 meters below my building or whatever that might be. And I'm happy with all these. Remember the walls with no thermal properties? We can start driving some performances to that as well, right? So how do we do that? Well, it's going to basically locate your building. Say my building's in Boston. Fenestrapro will look up and say, Massachusetts has adopted, and I don't know, I'm sorry to any Massachusetts attendees here today, but let's say Massachusetts has adopted ICC 2015 or the New York Energy Code or whatever that might be. The appropriate code will drop into this little panel sub-menu here. So, we might see an ICC, we might see an ASHRAE 90.1, and we might see even things that you've created and shared with your own team. I'll select this one, or I could even create a code, and that brings me to my platform. It's actually open a browser, and I can log in. Hopefully this isn't going to cause me problems here. Thank God for password managers. I can go in and create my own code with my own prescriptive values, my own glass to wall ratio, create that, share it with my team or whatever. And then when I've done those things, it will drop in here. Let's just choose this New York Energy Conservation Code. There is a wall U value and a floor U value, etc., etc. So I'll choose those. And now I can set those values to very notionally to any different components that do not have values. For example, my external walls don't have values. I can set the values from that underlying code, and that external wall will now have a U value of 0.44, or the roof a U value of 0.28, etc., etc. So as quick as that, no kind of needle in a haystack. Where's my issues? Where's my warnings? Where's the problems? Why isn't Fenestrapro working? Why isn't my energy analysis model loading? What's going on? I don't have time. I'm closing it and I'm just going to move on. It's just very intuitive and very quick to start, adding these properties. Then it's into a simple calculation, right? So as I said, the first time we apply Fenestrapro, it's going to go through this process and it's going to calculate your solar loads on all my different orientations, on any location, any orientation around the world, and including the effects of any shading, which is what it's doing now. So shading in the case of this building being my shading devices, but also if I'd massed up a number of buildings in that environment, we may have a 20-story tower, 30-story tower across the street, which is significantly shading my southern facade, and therefore, the amount of glazing isn't going to really hugely impact my solar heat gains and my cooling loads. Like I need to understand that. So that's what Fenestrapro is calculating. I can turn that, shading calc off, and it would have been open by now. But again, it's not that slow. It's pretty much done by now. And once you do it, it's cached, and you don't need to do it again unless you reorientate the building or relocate the building or add new features or whatever that might be. Then it probably is advisable to do it again and just do that kind of fresh calculation, So as quick as that, I did lots of talking and I did lots of padding around that, but that's pretty much the process. In terms of that troubleshooting, again, I was just looking at this really kind of small piece around, the properties of that glazing. We'll go back to that glazing in a second, but then, Dave talked about our kind of new viewer, the ability to do things much quicker, the ability to select a number of spaces, all together, and it's accumulating my values, looking at whether it's, peaks or averages or whatever that might be. But also I can start looking at spaces, rather than actually choosing individual facades. I'm going crazy with the viewer, sorry about that. Rather than looking at individual spaces, I can, select, rather than looking at surfaces, I can select spaces, and it will show me all of the heat gains and all of the daylighting in those particular spaces. I can also see the components within those spaces. So there's my analytical surfaces, to those spaces, and the architectural elements to those surfaces. I won't go through all the features and all of the bits, Dave kind of touched on that, but all of the stuff that we knew from Fenestra Pro and all of that business logic from before, including intelligently applying a glazing, from our database, and, some shading, etc. Being able to generate reports and, export all that information to my reporting platform, etc., etc. So, I think what we've done is a really great kind of step change in Fenestra Pro. I'll just go back to just that original piece of glazing and kind of just show you. Actually, I hope it is there because I didn't refresh it today. Yeah, it is there. So that piece of glazing there, where it was that glazed F Pro, SunGuard, blah blah blah. We had no values, but now we have a VLT, we have a solar heat gain coefficient, and we have a U value, etc. So that's that kind of, just to bring a full circle, that's that kind of the ability to do that. So I'm not going to go through all these one by one because I've kind of done a lot of this. Just to recap, it's that kind of code compliance wherever you are and wherever we have codes for, be it in Europe or the United States. And, we're always adding more, but you can also create your own code, share it with your own, design team, override existing codes, make them better, or, a specific one for a project or whatever that might be. Navigation and selection is hugely improved. It's more intuitive, but it's quicker as well, and that's a big thing. And inside, I'll talk about inside real quick. We do, obviously, I talked about Autodesk. We do have good ties to Autodesk, and I think what they like about us is, we're answering similar questions to things like Autodesk Insight, but coming at it in a different way and a more focused approach on the facade, whereas Insight is obviously outside the Revit environment and leverages that, again, that energy analysis model, brings it to a platform, and it looks at the whole building energy performance. It's outside, and it's quite broad stroke when it comes to the envelope and the facade, right? You can only apply a window to wall ratio for an entire facade, or you can only apply a type of glazing for an entire facade. Whereas Fenestra Pro, you can drill in and select individual spaces or windows or glazing, curtain wall assemblies, and make them all different stories, different orientations. And the upside is Insight can read that as well. So, we can get a little bit more into the nitty gritty, and Insight will leverage that when you do bring it out into that platform. So again, we've done loads with those guys, and we hope to do more. Dave, I'll throw it back over to you. I can hang on to the screen, or you can take from there.
You can hang on to the screen. There's one or two questions coming in I'm going to touch on in a second. But before we do, just to mention, for those of you who know, we've got a couple of users on the call, as well as obviously those who are looking at this perhaps even for the first time. It's a free trial available. It's that fenestrapro.com/free-trial. That'll take you to that page. And I think there's a QR code there as well if you're that way inclined. So if you just hit the button there. There you go. There's a QR code that will take you to find out more information in a free trial. One question that we had in there, I've addressed it directly, but I'll just address it to the group. So does the shade need to be modeled using certain family objects in Revit, or can the shade be modeled as a generic model and still recognized as a shade? So my understanding and my answer to that one was that once it's modeled as a mass object, then therefore it becomes part of the shade. Am I right? And that's how I answered that correctly, Simon?
I'm pretty sure it can be modeled as anything now, and it's being recognized as a providing shading to the building.
It doesn't have to be a particular family or a certain type of object. I
I
remember previously it was a
yeah.
mass object that we had to have.
Yeah.
But obviously that's improved now with version 7.
Yeah, I think so. Yeah, mass objects probably the easiest, the quickest, and we can drive mass objects as shading devices in that detail environment. But I'm pretty sure even if you put a louver device, it will, it will recognize it quite well.
Okay, great. Meg, was there any other questions that we see there? I don't see any other ones in the chat box. There's one in the Q&A. So I think it's, I think we at the early part of the presentation, we led and we start talking about operational carbon and embodied carbon. I think this might be a good opportunity just to kind of give a high level overview. Sorry, before we do, I was leading well into that. Does the daylight modeling meet the IES LM 8212 requirements, allowing the use for LEED daylight credits? I think, okay, I don't know the IES LM 8312 requirements. So what we use is design daylight factor. So again, what we, within Revit, you can get into that kind of daylight autonomy where you can look at those, the more detailed distribution of daylight on the actual floor plate as a result of different window configurations. What we do is we look at design daylight factor, which is basically the distribution of the external lux levels on the internal working plane. So it's a percentage of your external lux level. So for example, typical clear sky will be 10,000 lux. What we're looking for is 5% daylight. That's your optimal daylight within a space. 2% is minimum, and 2% and 5% is 200 and 500 lux equivalent. So we're looking to give it that kind of high level design or overview to provide you with just indications as to that you're getting a reasonable level of daylight in the space. To answer your question, Simon, you're a lead green associate, if I'm not mistaken.
What I would say is it's not a lead reporting tool. Fenestra Pro is more of a design tool, and it's not negating any kind of more detailed energy modeling or more complex analysis, to drive some of that compliance. I think Dave touched on it there. We don't calculate daylight autonomy. We do just very high level design daylight factors. So but there's lots of data you can drive out of that, and that's probably the best way. We could talk about it offline. I'm not sure who asked that question, but we could.
Tiambi Parish. That's great. Look, thanks for the questions. Good to get questions. Kevin, I see you've also put in a nice compliment. Kevin, you'd have seen this from the early days, and obviously we're advancing to version 7 now. So look, thanks again for the compliment. So what I was just before we jumped onto those couple of questions, and I'm just checking if we need more. So as I said, we led with discussion around operation carbon and embodied carbon, and this is something that's coming more and more to the fore as we talk to you guys, our customers, our users, and even those who are looking to subscribe to Fenestra Pro. Embodied energy is becoming more and more important, and I think the opportunity to introduce operational carbon and embodied carbon from a comparative point of view is great. Recent advances, and I'll hand over the side to maybe talk us through this. Recent advances within Revit, particularly Revit 23, where they've introduced a thing called systems analysis, which now they've connected Revit to Energy Plus, and that gives us the ability, as we're looking to now look to add additional metrics when we look at, particularly in the short term, operational carbon. So again, being able to get an operational carbon figure into the into your data sets, but also then adding in that embodied carbon. So do you want to pick it up from
there? Let me just add to that if I could. I don't want to get into the weeds in this because it's in development. And also we've 5 minutes to the top of the hour. I'm sure people are at lunchtime and all that kind of stuff. I just wanted to touch on it, that it's something that we're really excited about. You know, Dave talked about those kind of how important the facade is on a building. We all know that as designers quite intuitively, but like when, as he put a bit of context on the operational energy and the embodied carbon, I think as designers, it's becoming more and more important to understand our envelope through a, you know, that idea of whole carbon or total carbon, or, you know, looking at the, you know, the way I talk about it sometimes is like, you know, capital expenditure versus operational expenditure, and what does it mean in total, you know? So leveraging a couple of those things that Revit are doing. First of all, the systems analysis, and, you know, from Fenestra Pro, we're kicking that energy plus calculation to understand some of those loads, whether they be heating, you know, heating loads or cooling loads, etc. From there, we can start scraping that data and filtering that data, you know, using it for specifically around those areas that Fenestra Pro looks at, be it, you know, the facade and the envelope, etc. Likewise, Fenestra Pro are doing really great, or sorry, Autodesk are doing really great stuff with regards to embodied carbon in their new Carbon Insights tech preview, and they're leveraging the EC3 database on embodied carbon values of different materials, you know, to give you that overall around the entire building. And likewise, if we can drive that, we can scrape that information relating to the facade and relating to the envelope. So what we're effectively then talking about doing is providing like an insight or a snapshot on your facade, and how does it relate to operational carbon and embodied carbon, right? So this didn't animate, but like, let me talk through one by one. So we'll have the entire operational energy use of my building, and that which is influenced by the facade. Remember what Dave talked about, you know, artificial lighting, cooling loads, heating loads, etc. You know, what is that 57% or more or less that's influenced by your facade. Likewise, this is the total embodied carbon of my building. This is the facade, or this is the envelope, and, you know, whatever that might be. So the relationship, that 25, 26% or more or less. When I have these two things, then I could start getting a little bit more intuitive, right? I could say, okay, so over 20 years or over 25 years, the operational carbon of my building will look like this, and the embodied carbon to construct it will look like this. So, you know, it's just a very interesting sort of, you know, overlay on in terms of those two things. We could start looking at payback, or we could start looking at how it influences, you know, near zero energy buildings, or, you know, as we maybe look to refurb it in 10 years time, what could that look like? Or, you know, there's lots and lots of ways we could go with that. So what I'm going to do is, we actually have a web page around that, and we're actually going to update it because we've lots more information to show. But I've just dropped a link into the chat, and we'd love to hear any comments or any feedback from people. Happy to speak to people. We're actually doing some market validation and understanding users and customers, and, you know, what people want to see and how they want to see it. So believe me when I tell you, and I think lots of people will testify to this, that like, if you talk to us, you'll see what you're suggesting. You know, we're not Autodesk. We're quite small, nimble, and quick to, you know, to take this kind of feedback and apply it to our product and to our application. So we'd love to hear from you. And on that note, it's just 6 p.m. here in Dublin, and wherever you are, I'm sure it's the end of lunchtime. So we could probably wrap it up there.